Okay, problem 8.5. Suppose we have a random sample of size n1 that follows the Bernoulli distribution with theta 1 as a parameter, and a second random sample of size n2 that follows the Bernoulli distribution with the parameter theta 2. So now let theta 1 hat and theta 2 hat be the random samples. The sample means of these two random samples. That means the theta 1 hat is just the average of this, okay, and the theta 2 hat is just the average of this. They are both they're just sample means. Okay? So as random variables, we want to show that the expectation of their difference is just the theta 1 minus theta 2, which are these two difference of these two parameters. And the variance of their difference is actually equal to this. Okay, so we know that the theta 1 hat, which is a sample mean of the first of this random sample, it has the same mean as this random sample because every one of them follows the same distribution here, and the mean is theta 1. The variance is theta 1 times 1 minus theta 1. Right? That is the mean and variance for each of these guys. So the sample mean has the same mean as those guys, which is again theta 1. And the variance of the theta 1 hat is just the variance of these guys divided by n. So the variance of those guys, we said that it's just the theta 1 times 1 minus theta 1. That is the variance of a Bernoulli random variable with the parameter theta 1. So that's this. That's the variance for each of those samples. In because this is a sample mean, so that should be, you should divide that variance by n1, which is the sample size. And now then you get the variance of the sample mean. Okay, that is this variance of theta 1 hat. So similarly, you have the mean for the theta 2 hat and the variance for the theta 2 hat. Now let's see this. From this, we can easily get the mean and the variance of their differences. Because the expectation of the difference is just the difference of their expectations, because the expectation is a linear operation, right? So we know that this is just the difference of these two expectations, but we have shown that the expectations are theta 1 and theta 2 for these two guys. So we have the theta 1 minus theta 2. That is the expectation of theta 1 hat minus theta 2 hat. So the variance is similar. The variance of the difference of these two guys should be equal to the variance of the first one plus the variance of the second one. Remember that first of all, we have this equality because the theta 1 and theta 2 are independent. Theta 1 hat and theta 2 hat are independent because they're from two different populations. They're independent. That's why we can just get this. Otherwise, we'll have the covariance term coming out, right? The second thing is that remember that even you have a negative here, the variance, actually we should have a negative variance of the negative of theta 2 hat, but you remember that when you pull out the constant out of the variance, you should square it. So the negative 1 squared, it becomes positive 1. That's why we just have variance of theta 2 hat here. And we already know that they have their own variances here. We just put that back in here. They will get the variance of their difference.